Hello everyone, welcome back to my channel. In today's lesson, we are going to discuss about the terminology of sets. Not all the terminologies we are going to discuss here today, but these are the most used terminologies on sets. As you can see here on the board, the first one we have is universal sets. The second one here is power sets, union sets, intersection, and the rest. So here we can see from the first one here we have, which is universal set and empty set. So for universal set, it contains all the elements on the set. So suppose you have two sets, A and B. So it means all the elements in A and all the elements in B must contain in the element U, in the set U. All those elements must be in U. So that's universal sets. Okay, so the other one here is empty sets. For empty sets now, you see the representation. You can either use this empty brackets or you use this phi symbol. Mind you, if this empty bracket has a phi inside, it's not an empty set. Then it becomes just a set, but not empty, like this. So mind you, this one is not empty sets. Okay, but this and this is an empty set. Okay, so take note of these two things. Sometimes you are given an element set, then you are given like this type of sets or elements in the set. They said identify if this set is an empty set or not. So no sooner you see this one, these sets contain an element known as phi. Okay, so now let's see here power sets. So for power sets, okay, this Venn diagram, let's just discuss. So now you see V has an element A, E, I, O, U, the 5 vowels. So it means all the elements in this set, let's say we have here empty set, we say here X. So X and A, E, I, O, U belongs to the universal set U. So it means this one is the universal set, which contains U and X elements. Okay, so now here power sets. For power sets here, we have a formula we use sometimes to calculate the power set of an element. So here we have, and it's denoted by P of A. If the set, for an example, we have A equals to A, comma B, then the power set of this will be, now we'll check the elements of this set here. Now we have 2. So the basic formula we normally use for this type of set is 2 to the power n, wherein n is the number of elements. Number of elements on the set. Number of elements in the sets. Okay. So now here, how many elements we have here is 2 elements. So A and B. So if you use this from this formula, 2 to the power n, which is 2 to the power 2 now, will be 4. So it means the power set of A will be 4 elements. So now if we solve this one, we try to figure out this using this formula. So now we have A, just 1. We have B. Okay. We have A, we have B. Then we have AB, A, comma B. Then the last one, we have the empty set. As I told you, any set that contains an element, be it any letter, is not an empty set. So here, in this one power set, we have A, we have B, we have A and B, and we have the empty sets. Okay? So now, again, let me just highlight you on this cardinality of a set. It's just the elements that belongs on the set. That's just cardinality. So now we come to Cartesian product. For this one, we have 2 sets, A and B. So now you are asked to find using the Cartesian product. It's just like simple multiplication. You are multiplying 2 numbers or 2 letters like matrices. You can multiply, you take the one letter or the one element, you multiply to the other, and you take the other one again, you multiply. It's very simple. Okay, so let's see here. So now we take this one, A cross B now will be, we take first A by this. So this we can say A, comma 1, Okay, that's the first set. Then A, comma 2. Okay, that's the other one. Then A, comma 3. A, comma 3. Then we come to B. We are done with A. Then we multiply again this. B, comma 1. B, comma 2. B, comma 3. Okay, belong to all these sets. I hope this is clear, right? So multiply, we first take this first letter and the rest of the elements. Then we take the second letter and the rest of the element. That's Cartesian product. So the next one here we have is union. So for union sets now, you have two sets, A and B, for an example. So it means if you want to combine these two elements, two sets, all of them together, so it means you can take all the elements in A and all the elements in B and combine them together. But mind you, when combining these elements together, no repetition is allowed. For an example, you have 1, 2, 3, 4, then 4 maybe is repeated or 5 is repeated. So eliminate the repetition and just give your elements. So let's see here an example. We have A, 1, 2, 3, 4, 3, 3, okay, 3, 3, and B, you have B is equals to 2, 5, 6, 7, 3, 8, for an example. So now A union B, this union is denoted by this symbol U, like you can see, means union. So A union B now will be, so here we check. All the elements in A and all the elements in B will combine, but no repetition. So here we see we have 1 here, here no 1. Okay, we take first 1. 2 here, here 2 here, but we take 1. 3 here, here again, 3, we take 1. 4 here, here no 4, but 4 must be included. 4, 5, 6, 7, and 8. So as you can see here, no repetition, but all the combination of the sets are all clear, right? So these A and B are combined together, then we have our union. So for intersection of a set, it's just like similar to union, but I can say for this one, we find the common elements on the sets for intersection. If you have two sets again, A and B. So between these two sets, you have common elements that can exist in A and exist in B. So these two elements, the one that can exist on both sets, we combine them, that's the intersection. So here is an example again. We see here we have 1, 2, 3, 4, 5 to 6. Here we have 1, 2, 5, 6, 9, and 4. So now we checked for the common elements on the set. Here you check. You have 1 here, you have 1 here. Yes, 1 is common. You say it. You have 2 here and you have 2 here. Yes, 2 is common. You have 3 here, here no 3, no, it's not common. You have 4 here, here no 4, no, it's not common. 5 here, here again 5, yeah, 5 is common. Okay, 6 here, here no 6. So we only have 3 elements on this set that are common. So the intersection of sets A and B is 1, 2, and 5. So the last one here is complements. So for complements, we have universal sets. So all the elements on the sets, set U, we have two sets, U and A. So if we want to give A complement, it means we minus or we subtract the elements A from U. So here is another example for complement, U minus A. So it means we subtract these elements of A from U. So 5, 6, 7, and A will remove these elements on the set. And the remaining elements will just put the complement of it, okay? So here we have 0, 1, 2, 3, 4, and 9. So here the complement is 0, 1, 2, 3, 4, and 9. Okay. So now we are going to solve another problem here. So let's see. So based on the previous terminologies, so we are going to use these terminologies and solve this problem. But here we have 4 basic properties we are going to use to solve Short's problem. Okay. The first one here is idempotent, which says A union B must be A. So if you combine 2 sets, A and another set is A, so the result is supposed to be A. Else, this law is violated. So also this one, commutative. So if A union B, then the reverse must occur again. If the reverse is not taking place, then your commutative law or property is not correct. So the other one is associative, and the last one is distributive. So here on the board, we have a simple problem here we can solve, we can use to solve based on these properties. But for this lesson, we are just going to use commutative property and this associative or distributive. Okay, so you try the next one. Maybe I will solve either commutative or associative, then you solve this distributive. The approach is the same. So let's see, we have a problem here says prove the basic property of the set. So let's prove the property of this set A, B, and C if it's commutative or not. Okay, then later you can solve this associative or distributive. Okay, so now we have A union B. First, what you're supposed to know is the rule. Okay, the rule of commutative says what? If A union B must be B union A. That's commutative. Else, if this is not met, this condition is not met, then your answers are not correct. So let's start. A union B. A union B must be B union A for commutative to be for commutative. Okay. So on the previous video, I dealt with this union. So for now, I know you must understand what union means, what intersection means. So what applies here for the union must also be applicable to intersection. That's why I say union of the union and intersection of sets. So now A union B. So let's try to see here. Union simply means the simple or common elements on the sets. You combine everything, that's union. So if we say A union B, means we combine all the elements in this set. So we start from 2, but mind you, repetition is not allowed. So we say 2, 3, 5, 4 here, yeah, 5, 6, and 7. So now A union B is equals to these elements on the set. So now let's say B union A now. So for B union A, we try to check again. So here we say again 2, 3, 4, 5, 6, 7. As we said earlier, all the elements in A and all the elements in B, but repetition is not allowed. So here, this condition is satisfied. As you can see, all the elements present in A union B are equal to this B union A. So let's check for intersection again. A intersect B and B intersect A. So A intersect B is equals to B intersects A. So we'll prove this again. First, we take A intersect B. A intersect B. So here we see the common elements on the set. The elements that are in A and B only, but not all. Okay, you can't take all the elements, only the elements that are common you take out. So let's see here, A intersect B, 2 here, 2 is here, but 2 is not here, so we ignore the 2. 3 is here and 3 is here, okay. Say 3. 4 is here, but here no 4. 5 is here and 5 is here, so we'll take 5. 6 is not here. 7 is not here, so the intersection of A and B is 3 and 5. So we'll check again for B intersects A. So it's the same, 3 and 5. Okay, so 3 and 5. Therefore, this is commutative. So the set is commutative. So now let's try to check for the associative property, which says A union B, A union into B union C. So we see here A union B union C must be equals to A union B union C. Okay, so here we'll first take B union A, the results will combine to A. B union C, the results will combine to A. So first we say B union C. What are the elements present when you combine this B and C? So B and C here, B and C, we take all the elements in B and C. So we have 2, 3, 5, 6, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and 7. Okay, so now we'll combine this B union C, we'll combine it to A. So now we say A element is 2, 3, 4, 5. Therefore, A union B union C now will be A union this now. Since it's union, we take all the elements, okay? But we are not going to repeat. So we take 2, 3, 4, 5, 6, and 7. Okay? So for this one, we are done. So let's check now if this element here is equal to this one. So here, A union B. So first take this one, A union B. From here, A union B. So of course, we already have here A union B. A union B is 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So our A union B is this. And C, mind you, C is 2, 5, 6, 4. And C is 2, 5, 6, 4. Okay. So now A union B union C. So we already have A union B, then we union A union B and C. So now our results will be C. We compare these two. 2, okay. 2, 3, 4, 5, 6, and 7. So here you can see A union B union C, A union B union C is equals to A union B union C. A union B union C. Hence, this one again is associative. So the last one here, let's check for this distributive. For distributive, we say C intercepts A union B. So first we consider the union and later we intercept to this outer variable. So first we take A union B. So A union B, we know already A union B, which is 2, 5, 6, and 4. So now we just combine this A union B with C. So C intercepts A union B. So what will be our results? C intercepts A union B. So first we find C here. We have here C. C is 2, 5, 6, 4. Sorry, A union B is not this. This is C. 2, 5, 6, 4. That's C. Okay. A union B is 2, 3, 4, 5, 2, 3, 4, 5, 6, and 7. And our C is 2, 5, 6, 4. So now C intercepts A union B now. Here we find the common elements. That will be our results. The common elements for this A union B and the intersection of this C. So the common elements here is 2, 5, 2, 4, 5, and 6. So it's 2, 4, 5, and 6. Okay. So now we checked for C intercepts A union this one. Mind you, let me just make this clear. This one is equal to this. If you want, you can use this to solve this type problem, or you can break down the problem to this. C intercepts A, and later you do a union for A and B. Okay, this is just an expansion of this. You open this bracket, C intercepts A, and the union is between this A and B. So C intercepts A, union C intercepts B. So it's just an expansion. So you can either use this or use this. So for me, I'm using this first one to see. So now we'll check for the other one. C intercepts A, C intercepts A, union A intersects B. So C intercepts A. Let's just go direct to the answer. From here, C intercepts A. So we'll check for the common elements on A and C. So the common element here is 2, 5, 2 and 5. 2, 4, 5. 2, 4, 5. So this is 2, 4, 5. Union A and B. A and B, the common element is 3, 3 and 5. A and B, 3, 3, 5 is 3 and 5. Okay. So now let's combine these two. We combine this and this. We have 2, 3, 4, and 5. Okay. So we'll check for this one again. But here you can see this one we only check for this and this. We only check for this and this, and now we try to compare if this answer here is equal to this one. So we'll check this answer. If this answer is equal to this, then it means this is distributive. Since, as you can see here on the board, these two answers are different, so this is not distributive. This is not distributive. So thank you for watching this video. Don't forget to subscribe on the channel, like and give your comments.